Alright, problem 7. The speed of a road biker traveling from Boulder to Ward in miles per minute is given in the chart below. We want to use a midpoint rule with 4 equal sub-intervals to approximate 0 to 160, the integral from 0 to 160, v of t dt, and indicate units in our answer. So 4 equal sub-intervals, so think about how that's going to be broken up. It's going to be like, oops, sorry, I always goof this up. So if you can picture my 4 sub-intervals like that with those midpoint values right there, we could also say 160 divided by 4 is going to be 40 to see that each width should go 40. So 0 to 40, then 40 to 80, then 80 to 120, then 120 to 160. So let's now use a midpoint rule. We know that the width is 40, and we need to multiply that by all of the heights coming from the midpoint. So 40 plus 0.25 plus 0.1 plus 0.2 plus 0.16. Crunch that, and you should get 28.4. And what are our units? Well, we're multiplying minutes by miles per minute, which will give us miles. And so we get 28.4 miles using that midpoint approximation with 4 equal sub-intervals. And now we want to do a similar thing, except this time we're going to be doing a trapezoid rule with 8 equal sub-intervals. So this time we're going to be having a width of 20 instead of a width of 40. So this should be more accurate of an approximation, most likely. So what are we going to do? Well, we're going to multiply all of the heights in a special way. Remember that the first and the last height get used once each, but everything in the middle gets used twice. The width is 20. We need to divide that by 2, because of the formula of a trapezoid is base 1 plus base 2 times the height over 2, or the width over 2, however you want to think about it. So I'm going to be multiplying 10 by my first height, which is 0.3, plus 2 times all my middle heights, 0.25, plus 0.15, plus 0.1, plus 0.18, plus 0.2, plus 0.22, plus 0.16, close that parenthesis, that's the end of the doubles, and then plus that last 0.1 just one time. Crunch this, you should get your value for this approximation for the trapezoid rule. So with this approximation, you should get 29.2 miles, which is probably more accurate than that midpoint rule was, just because we had twice as many sub-intervals, giving us a little bit less error. The more sub-intervals you can have on a given interval, the more accurate your approximation should be. Again, units are miles, because we're taking miles per minute, a speed, multiplying it by minutes to get our distance traveled between 0 and 160 minutes. So roughly 30 miles.